HanselMinutes.com. It's Hansel Minutes, a weekly discussion with web developer and technologist Scott Hanselman. This is Lawrence Ryan announcing show number 193, recorded live Thursday, January 7th, 2010. Support for Hansel Minutes is provided by Telerik RAD Controls, the most comprehensive suite of components for Windows Forms and ASP.NET web applications. Online at www.telerik.com. In this episode, Scott talks with Niklas Gustafsson about the incubation project Axum.
Hi, this is Scott Hanselman, and this is another episode of Hansel Minutes. And today I have the pleasure of speaking with Niklas Gustafsson, a principal architect on the parallel computing team. How are you, sir?
Oh, hi, Scott. How are you?
I'm pretty well. So I'm glad that you took the time to sit down and chat with me about this, because we've got an interesting topic today. We're talking about Axum, formerly called Maestro. And this is something that is part of a labs incubation. This isn't a product yet, right?
Yeah, that's correct. So I think it's important to explain perhaps then what incubation means at Microsoft. There are often times when, based on just market research and understanding our customers, through decades of having relationships with developers, we just sort of understand exactly what the right thing to do in a product cycle. But often it's also the case that we, and particularly for perhaps more advanced, quote-unquote, advanced projects or things that we may have some doubts about, it's not always clear exactly what it is that we need to produce. And this is where incubation, or whether even things are feasible to do, and this is where incubation fits in. It's not research in the sense of trying to advance the state of what is known, if you will, but it's really trying to advance how things are applied and what technologies that are already established are feasible to produce as Microsoft products. And this is where Axum comes in also. It's an incubation project at Microsoft within the developer division.
So did it come from research? I mean, what is the process from someone has a thought to someone in Microsoft Research has a thought versus someone spins up an incubation project within the developer division itself? Yeah,
so I would say that it's inspired by research, but not just by research within Microsoft, and not just by research either. It's also inspired by other products that are out there. You start with a problem that you see not being solved adequately, and in current products, and a customer need, and that customer need may not be so immediate that you can find it or sort of evaluate it through sort of market analysis or research from that perspective. You have to sort of develop a technology prototype, and you have to try it with customers. And this is the sort of the approach we took with Axum. It's inspired by what's commonly referred to as actor-based or actor-oriented programming. It's also called agent-oriented programming. And the idea there is that instead of relying on access to shared memory or shared state, and coordinating that access through locks and other forms of synchronization primitives, you isolate state within agents, and you use message passing between the agents to synchronize and exchange information. But each piece of data is at any given point in time in the program owned by only one single-threaded entity. And there are other languages that do exactly this. Erlang is an example of a functional, a pure functional language that takes this approach. There are elements of actor-oriented programming in languages like Scala and F#, but Axum really tries to take it one step further and really be pretty rigid about the isolation enforcement. Neither Scala nor F# really enforces the isolation. It just sort of suggests that it's a good thing. They take the pattern but don't quite enforce all the constraints that are necessary to make the pattern completely safe. So one of the questions for us, and this is why you want to test this, is how critical is that enforcement? How critical is it to go beyond what you can just do in libraries and really implement this model, this pattern in a language?
Well, that was my next question, is that, F# and functional languages make the decision to be functional. They exist to be functional, and you get the benefits of being functional, with, not having shared state, but they don't necessarily exist to be parallel. Are you saying that Axum, puts a stake in the ground and says we exist for the purpose of being parallel rather than just to be functional?
Yes. And those are not necessarily coupled to each other either. A functional programming language need not be parallel. Erlang is an example of a functional language that is designed to be parallel as well as functional. Axum is not a functional language. It has more in common with C# than it does with F#. And one thing to keep in mind about F# and Scala is that they're both functional languages and object-oriented languages. So there's sort of a mix of the two. And any object-oriented language will be dependent on shared state and shared memory. Now, what we're trying to do with Axum is to take an object-oriented context rather than a functional context and provide some isolation around state with an actor-oriented model that's sitting on top of a object-oriented environment, rather than what Erlang does is to do it on top of a functional environment.
Now, why wouldn't you take an existing language like Erlang or Scala and make a .NET version of that? Why create a new syntax?
Well, let's talk about Erlang, because Scala, I think that there really is. I mean, F# is to .NET what Scala is to the Java virtual machine. But if you look at Erlang, it's a pure functional language. It wouldn't be very straightforward to take a language like that and put it on .NET without giving up a lot of what .NET offers. So, for example, most of the .NET class libraries are built on the assumption that you're really going to be using them from an object-oriented language. They're really very, quite stateful class libraries. They are they really operate on the idea that you're manipulating and modifying objects. And so to build something like Erlang, which has a data model that is, first of all, completely dynamically typed, and is further built on the idea that all state is immutable, all data is immutable, and that you mutate state by building new copies of the data that, rather than changing data, you create new copies. So it's a completely different model. You wouldn't be able to leverage a lot of what .NET has to offer in terms of built-in types and class libraries if you try to build Erlang on top of it. So what Axum is trying to accomplish is to build a model that works well with .NET and which leverages all of .NET, and where you, in your Axum program, you have access to all of .NET and can use it productively, but add some measure of isolation on top of that and some measure of safety on top of that.
And this was something that needed to be another language as opposed to being some kind of extension, or like the way that, could you not have created some, have basically spot welded something onto C# itself?
Oh, we could, and absolutely. And this is one of the questions, when you go from incubation to productization, what is the right strategy to take there? What we wanted to do was we wanted to have we want to have more degrees of freedom, if you will, in our experimentation. That's what incubation is about, after all, is experimentation and finding the right solution without being, in the early stages of your development, being too strictly tied to some existing set of constraints. It may not really have anything to do with the problem that you're trying to experiment with. So doing it as a separate language gives you a lot more freedom to experiment.
That is actually a very good explanation. That makes a lot of sense. Because I think that sometimes people look at these things from outside and they just go, what is going on inside of Microsoft? They're inventing new languages. There's these problems are solved. But you're right, from a Skunkworks perspective, it's much more freeing for you to explore the space with a fresh language and a separate compiler than it would be to try to shoehorn an existing thing on top of the CLR.
That's right. And so that's the primary reason for doing it as a separate language during the incubation phase. Now, that leads to the question of how would you really productize something like this, and what would it look like? And those are questions that we're thinking about, right now, and as next steps, and whether it's all of it that makes it into. You could wind up with a solution where certain aspects of a language like this make it into into some languages, and other aspects of it make it into other languages. It's all sort of unclear at this point what the right solution is. And it may actually be that the right solution is to have what I call a special purpose language, which is what we sort of build Axum as. One where you would expect users to write only pieces of your application in that special purpose language, and then the majority of your application would probably be written in a general purpose language such as C# or Visual Basic.NET. That's something we're struggling with right now, but it's not part of the incubation problem domain, if you will.
What is the contract between you and the people who are involved in an incubation? If someone decides to build their business around an incubation project, that sounds like they're taking a pretty big chance. Is that pretty clear up front? I mean, what is your obligation to them to support this thing that is not supported? So
one of the obligations is to be very upfront about what our commitments are to a project like this, and being very honest and direct about what we mean by incubation, and the fact that this is something that is intended to inspire thoughts and inspire ideas, and inspire you as a user of it, or somebody who picks it up and experiments with it, to rethink maybe how you're looking at problems, and maybe just expand your the way that you look at the future of parallel programming. It's not, and we've been very clear about this throughout, and I want to reiterate it now. We're not committing to shipping this in this form at all. We're hoping to, but we're not saying to anybody that this is a for sure thing. So, we certainly don't recommend anybody to build a business around it. That would be taking a huge risk. But what we do encourage anybody to do is to get it out of the DevLabs, try it out, and contribute thinking to this problem. And is this the right solution? Are there things missing? Is there too much in it? One of our concerns is that Axum is a lot bigger than perhaps is feasible to try to introduce in .NET right now, or in sort of the market right now. What is the minimalist approach to this problem? What can we yank out of Axum as it is defined right now, and wind up with something that is mostly as powerful as what we've defined?
Do you know how to make the possible out of the impossible? Well, the .NET ninjas at Telerik do. They just released a huge pack of web controls all built on top of ASP.NET Ajax that'll help you build impossibly fast and interactive applications in no time at all. They've made the impossible possible in desktop development. If you think you can't have a carousel component in WinForms, well, you can. Their Windows Forms suite features a super powerful grid view control and 32 other crazy desktop components that'll give you dazzling WPF-like features, but in WinForms. They do the same thing in reporting solutions with a new design surface like nothing else. Looks just like graph paper. Gives you advanced page layout capabilities. Makes it feel more like a graphic design software than a reporting solution. Go check them out at Telerik.com and be a .NET Ninja. And thanks for listening. Now, I know that everyone is thinking about parallelism at Microsoft right now, and I've talked to various folks about how to make parallelism accessible to the masses. And I just literally last night put together a very inexpensive machine with a friend of mine that had 8 cores. I feel like, we're going to blink and there's going to be 16 cores on the desktop, within a year. Mm-hmm. This is part of that larger kind of push towards making parallelism accessible to people?
Yeah, so I think that's absolutely right. One of the major problems with the tools and what we have, platforms that we have available today, is that they were built for concurrency, where you have limited needs to run things in parallel, and they're typically driven by either the need. When you had it, it was either because you were trying to unblock a GUI thread, for example, or you were trying to leverage latency in terms of, while you were doing disk I/O or network I/O, you were doing other things so that the overall application responsiveness would be higher. With all this power, where you have 8 cores, I have an 8-core box at home, mm-hmm. and if, of course, 99% of the time it's completely idle, and a little bit of the time it runs maybe 5 or 10% of its capacity, and very rarely does it actually use all of its capacity because the applications just aren't written for it. And now we have all this capacity. We can use it for parallelism, where you're actually trying to take an algorithm and run even just the computation, not just overlapping it with I/O, but run the computations inside the application in parallel and speed up how quickly computations finish. That will give us just completely new opportunities for new user experiences, and new, quicker, more in-depth analysis of data, and so on and so forth. But it's hard. Because we haven't built it for that type of. We haven't built the platforms for that type of usage by sort of the developer masses, and even for the very advanced developers, it's tricky. Accessing memory cells, if you will. I mean, the current model we have is that you have memory cells and you have threads, and the threads are accessing the memory cells completely without any coordination, and any coordination by the system, that is, and all the coordination is responsibilities put on the programmer. And so we have a model that's extremely random, if you will, non-deterministic in its execution behavior, and we're asking developers to rein in that non-determinism.
Right. Now, this is really interesting. I think that you there's almost a throwaway statement in there, but I think that really, for me, crystallizes the whole idea that we're running around and we're accessing memory in a fairly ad hoc way, and the responsibility is on the programmer on how to manage these shared resources. And there's a really great blog post up on MSDN at the older site called Maestro team, back when Axum was called Maestro, that has some visualizations that really explain that. So maybe we can change gears a little bit and talk about this, because this really crystallized it for me. Like, we've been talking for a while here, and there may be some folks that have felt we've geeked out a little too much and forgotten to talk about, like, what exactly is this thing? And you give an example of a multi-threaded application where we're going to run through a list of items that are in some shared state and sort them and put them back together. So it's a very contentious application. And there's this wonderful visualization that shows how much waiting for locks is going on. You've got all this parallelism, and the worker threads, the parts of the application that are doing the work, they go work, work, work. All right, I'm done. Now I'm going to get in line to tell you about the work. And then they wait for a while, and then they work, 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 and then they get in line to tell you about the work. But then when you introduce a message passing algorithm, you've got one thread that's doing the updating of the data structure while the worker threads actually work. And it really got me thinking that I think most of my worker threads aren't working at all.
Right. And that's correct. I mean, you're spending so much time synchronizing and and worrying. And to some degree, it's a performance issue, right? To some degree, it's a productivity issue because the amount of time you spend debugging your ad hoc methodology for synchronization is tremendous. I mean, we have lots of data that supports this, that developing concurrent applications is many times less productive than developing a sequential application because of the ad hoc methodologies that are available. Now, so what Axum is trying to do there, so it's trying to put some constraints on this. And this is another reason why languages are necessary, because frameworks are good at enabling, not constraining. And what you really need to do here is you need to constrain the patterns that people can use for parallelism.
Right. So you're setting them up for success in parallelism.
Yes.
By following the rules and the framework that you've laid out, parallelism will just happen.
That's correct. And you won't even think about it. So the idea is correct by construction. In other words, that if you write your parallel application in Axum, it will enforce a pattern for your application that is safe, inherently safe, from data races. That is, these the accidental reordering of access to memory cells. There are other hazards in parallel programming, like deadlocks, that Axum does not necessarily deal with.
Well, that's an interesting question. Then, what doesn't Axum deal with well?
So deadlocks is the primary one. Now, deadlocks, fortunately, is among the problems that are hard to debug in parallel programming. Data races is by far the most common first, and then also extremely hard given the tools that we have today. Deadlocks are fortunately, I mean, sometimes they're quite intricate, but you usually hang and you know that you have it. The signs are there for you. You know that you have it. Data races can be extremely hard to detect because the side effects of data races are sometimes benign and sometimes not, and they're very intermittent. Deadlocks, you just break into the program with a debugger and look at where all the threads are. Fixing the problem could still be a challenge, but at least you can detect it much easier. So one of the things that we're doing in Axum, and we have this thing called a protocol, where we define between agents, we define communication channels. This is for where the messages are being passed between agents. And we actually add formal protocols to those channels. And once you have the formality so the protocols express the order of messages that can go between agents. And because we're not allowing you to take locks in Axum, agents cannot synchronize their actions using locks. You can't have any deadlocks through locks. All your deadlocks can only happen through messaging, where you're trying to access, you're doing things. You're expecting some value from me, and I'm not going to be sending it to you because I'm expecting a value from you. That's kind of the message passing deadlock, if you will. But by defining formal protocols for how you and I, if you and I are agents in this program, how we interact, we can get rid of a lot of deadlock situations. If we also add some more advanced analysis tools, static analysis tools, that compare the code I write in my agent against the protocol for the communication channel and see whether I'm really following and living up to that protocol or not. And this is not something that still remains to be incubated, but it's something that theoretically should be straightforward to do. And something we've experimented within Microsoft, I wasn't involved, but Microsoft has experimented with in other research projects. So we have a theoretical solution to that. We haven't applied it, but on the data race side, we have applied it, and Axum, an Axum program should be free of data races if you use Axum sort of at the top of your application architecture, which is where it's designed to be or intended to be used.
So if someone sits down for this for the first time and they download this, they're bringing what onto their machine? Sometimes when I'm going to put something on my machine from Microsoft, I'm concerned that it's going to mess up projects that I'm working on. So what are the options for getting involved or getting started with Axum? Right.
So Axum is just the download is an MSI, just a regular installation image. It builds on top of .NET 3.5 and Visual Studio 2008 is expected. You can use just the command line version also, but we certainly recommend that Visual Studio 2008 is your environment for it. And there's nothing special about it. It just installs another language service into Visual Studio and adds a few libraries to your .NET environment and a few samples, and that's pretty much it. There's nothing special about it. It's just another couple of libraries and a compiler.
Okay, so it's not gonna put things in my GAC that are gonna make existing projects break.
No, it's not replacing anything. It's not patching anything. So it should be completely safe from that perspective. And the uninstaller, as far as our testing goes, seems to be working just fine. So cleaning up your machine afterwards is supported also.
So then the Axum Lite is the command line compiler if I just want to do things like in an MS Build situation, or if I really want to keep things isolated.
That's
but
correct.
I really should use the Visual Studio edition. And what does that add to Visual Studio?
It adds another language. So if you're familiar with sort of the Visual Studio environment, right? If you install not just one language, but the whole Visual Studio installation, with Pro or something like that, you get Visual C++, you get C#, you get VB. So Axum just shows up as another language, and with a couple of project templates and item templates in Visual Studio, and a sample directory. That's pretty much it.
So then I could just take an existing application and add a new library. So it would just be like having a solution with multiple languages. So I could have C#, VB, and Axum.
Yep, that's right.
Okay, now can I use Axum within an existing application? Or because we can't have mixed language assemblies in Visual Studio, we'd have to do that a different way?
Right. So that's a Visual Studio limitation in that you can't mix Axum and VB, for example, or Axum and VB in the same project, but you can have them in the same solution, of course.
All right, very cool. And one thing I'm curious about, and this is just a little bit of an obscure question, but I'm an Afrophile, and I noticed that Maestro makes sense as a name. This was the previous code name because a maestro is a conductor, and it's it's an evocative name. But Axum is a province in Ethiopia, and I can't think about it. I'm trying to figure out why you would name the product Axum. The thing that's significant about Axum in mythology is that they say that the Ten Commandments exist in a church in Axum in Ethiopia, but I can't tell if that means anything about parallelism.
So the tradition at Microsoft is that code names that are made public should be based on geographical locations, and so we just had to pick something, and we wanted to pick something that was a little bit obscure and not just something common. And I'm personally I'm Swedish, but I have some connections to Ethiopia, and I just decided that hey, that would be a cool name to have. But really, the obscurity of it was part of the charm of picking a name like that.
I think that's great. I was thinking before the interview, I'm like, okay, let me think. Well, the thing that's significant about Axum is that the Ten Commandments are there, and everyone wants them to be released, but no one's seen them. Maybe if Axum gets released from Microsoft, that'll say something about the Ten Commandments being released from Ethiopia.
No, I just wanted people to, when they heard the name, I thought it would be cool if people actually had to research what that was, rather than just
Well, yeah, mission accomplished. I knew immediately. I said, "Oh, wow, okay, that's a cool name." So the blog is called Maestro Team. Has that moved, in fact? Because you can find information about Axum. I was Googling with Bing, and I found Axum information in multiple locations. Where's the primary place to find the latest on Axum?
So there are two places. One on MSDN DevLabs. And the other one is that Maestro Team blog. It turned out that it was, while changing the code name was quite straightforward, particularly because we did it before we released it. Changing the blog address and so on and so forth, because we had lots of links everywhere. We just didn't want to go through that. So the blog is actually still blogs.msdn.com/maestro_team. But that is the official Axum blog. It's been a little bit inactive in the last couple of months because we really haven't had anything public to talk about Axum lately. But there's tons of information on there. There's a forum on DevLabs. Also been a little bit inactive lately because we haven't had anything public to release there. We haven't updated the Axum release in some time. But there's lots of information there, lots of things to go through and look at.
So it is alive.
It is alive. And the download is there at DevLabs, msdn.com/devlabs. And it has great samples. And those samples a lot of what the forum discussions are about samples and questions around it and elaborations on those things. So it might help to do the download and before looking at the forum.
Okay, very, very cool. I'll put the links for that up on the show site. That's msdn.com/devlabs, and there's a lot of different projects up there, one of which is Axum, and then blogs.msdn.com/maestro-team. And of course, if you just search on the web for Axum, AXUM programming, I was able to find all of these things, as well as some interesting presentations and videos at various conferences on this topic. Thanks so much, Niklas. I really appreciate your time.
Okay. Well, thank you, Scott, for having me.
This has been another episode of Hansel Minutes, and we'll see you again next week.